Hey guys, welcome to brainAttic. So today we have another very interesting problem from integration. Basically, this is an application of integration where we have to find the area bounded by a curve. So this type of question often appears in JEE Advanced or JEE Main or maybe International Mathematical Olympiads. Not in this exact form in which we are seeing, but in a different or a slightly different manner. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So let us begin. If AN is the area bounded by the curve y is equal to tan x to the power n and lines x is equal to 0, y is equal to 0 and x is equal to pi by 4, then we have to prove that for n greater than 2, an plus 2 is equal to 1 by n plus 1 and also deduce that 1 by 2n plus 2 is less than an less than 1 by 2n minus 2. So with the current format of JEE, such questions you will not see. But this definitely appeared in a very long time ago in JEE Advanced when it was called as ITJEE. But in IMO, such questions can still appear. So let's begin and give it a try. Now, since uh, 0 less than tan x less than 1 when x is in 0 to pi by 4. So what we need first of all is the graph of tan x. So if you recall, this is how the curve will approximately look like. And this is suppose your point pi by 4 comma 1. Tan pi by 4 is 1. So on the x-axis we have 0 and 1. This is your x-axis and this is your y-axis. So we have to find the area inside this region. So we know that since 0 less than tan x less than 1, tan x will lie between 0 to 1 when it is in the range 0 to pi by 4. We have 0 less than tan x to the power n plus 1 is less than tan x to the power n. Obviously, fractions will be increasing, the power of the fraction will reduce the value of the fraction when n belongs to natural numbers. So this implies that integration of 0 to pi by 4 over tan x to the power n plus 1 will dx will also be less than integration 0 to pi by 4 tan x to the power n and dx. So this therefore implies that an plus 1 is less than an. Now for n greater than 2, we have to find an plus 2. This, if you see, is fairly simple. 0 to pi by 4 tan x to the power n plus tan x to the power n plus 2 dx. We'll take tan x to the power n common, and what we are left with is 1 plus tan square x dx. Now, if you recall, this is tan x to the power n. This is nothing but secant square x dx. So this we can very easily write as 1 by n plus 1 tan x to the power n plus 1 and apply the limits 0 to pi by 4. And finally the answer is 1 by n plus 1. So we have proved the first part of the question. Now we have to go and deduce the second part of the question. So since an plus 1 is less than an, therefore an plus 2 will also be less than an plus 1 will also be less than an, correct? Therefore then we can say that an plus 2 is definitely less than 2an. Now we just derived that an plus 2 is nothing but 1 by n plus 1. So this is less than 2an. Therefore, we have 1 by 2n plus 2 less than an. Now again, an plus an should be less than an plus an minus 2. With the same logic, this will imply that 2an will less than 1 by n minus 1, and hence an is less than 1 by 2n minus 2. So therefore finally we have shown that 1 by 2n plus 2 is less than an less than 1 by 2n minus 2. So this is our answer, and we have reduced the second part of the question. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching the video.